This is the tutorial for handout number 2 titled Volume of Cones. And so let's take a look at our first problem here. And it says, what is the capacity of the cone? Well, capacity just is another phrase for volume, and so that's what we're going to end up finding here. So when we take a look at the volume of a cone, we've got to take a look at pi r squared, so the area of the circle, times by the height, but since we're dealing with a cone, it takes 3 cones to make a cylinder of the same height and radius of the circle, and so I've got to take a third of that answer. And so the first thing I'm going to end up doing is substituting my radius in for r. So 1/3 times pi times the radius of 4 squared, and then I'm going to multiply by 9, which is the height. So I just substitute it, and at that point I can go ahead and do some work. So I'm going to go ahead and deal with the exponents, and I see 1/3 of 9 is 3, so I'm going to reduce this fraction just a bit here. And so 1/3 of 9 is 3, and I can go ahead and take this 4 and square it and get 16. Well, 16 times 3 makes 48, so 48 pi would be the exact answer. Now if I want to approximate it, I'm just going to use that calculator function and come up with an answer from there. So let me pull up that calculator. So let's find that real quick. So we'll just plug in 48 times by 3.14, and we'll see what the answer is. 150 and 72 hundredths. And so if I was to round that to the nearest square inch, that would end up being right here. So again, that nearest square, or not nearest cubic inch, I should say, since we're dealing in volume here. Nearest cubic inch is the ones place. Ones place. So if I was to round to that, I would take that 7, and since it is large enough, it would change it to 151 inches cubed. That's only if they asked for that. So the next one here says the volume of the cone, and then they give us the volume here. And the height is 9 inches, and so they want to know the diameter, and that's what they're trying to find. So let's start off with our formula. Volume equals 1/3 pi r squared times by height. So I go ahead and substitute what I know. I know 339 and 12 hundredths is the volume. I've got 1/3 times pi. Well, I'm looking for the radius first. Again, I want to find the diameter eventually, but I'm going to find the radius first, and then I times by 9 since that's the height. So from this point, I again could take 1/3 of 9 is 3, and that just makes the problem a little bit easier. So now I have 339.12 equals pi r squared times by 3. Well, I'm going to go ahead and divide by pi, and so when I do that, I'll plug that into the calculator. So I've got, clear this last one. So I've got 339.12, and I'm dividing that by 3.14, and that gives me 108. And so I'll go ahead and write 108 equals r squared times 3. So now I can get rid of that 3. So I'll divide both sides by 3, and 3 goes into 10 3 times, with 1 left over. It goes into 18 6 times, so 36 is what I get when I divide 3 into 108. But that's not r, that's r squared. And so again, it's real important to make sure you bring down the equal signs each time, bring down the variables, and look to see that that's squared, so I need to take the square root. So when I go ahead and do that, I end up with 6 equals r. But remember, that's not what I want. I want the diameter, and the diameter is always double the radius. So 2 times 6 gives me 12, and these are in inches, and that's the diameter. Now let's take a look at our next problem, and it says that they're asking how many times do you need to fill the funnel in order to fill the cylinder. So here's the cylinder, and we're going to fill the funnel with some sort of liquid, and eventually we'll fill up the cylinder. So let's do this. What we want to do is we want to find the cylinder's volume, and then we're going to find the cone's volume, and we're going to end up dividing, because the cone's going to be a little smaller, definitely looks smaller, and it is because you see how the radius is smaller, the height is definitely smaller. And we're going to divide, see how many cones it's going to take to fill the cylinder. So let's start off with our formula. The cylinder formula goes pi r squared times by height. Since the radius is not the same, I can't just cancel things out. Height's not the same either, so I need to actually do the work. So I'm going to do pi times the radius, which is 6 squared, times by the height, which is 10. Oops, I'm looking at the cone, so let's fix that. I should be looking at the cylinder. So the cylinder has a radius of 8 squared times by 56.25. And we'll go ahead and do some work there. So pi times by 64 times 56 and 25/100ths. So let's go ahead and figure out what that multiplication is. So 64 times by 56.25, and that gives me 3600. So I'm going to leave it in terms of pi because the cone also has pi in it. So its formula goes this way again, 1/3 pi r squared times by height. So that's what I'm going to be dividing by. That's why I keep on bringing down this division sign. So 1/3 times by pi times the radius, which is 6 squared, times by 10. That's the information they give me up here. So I go ahead and do a little more work. 1/3 pi times by 36 times 10. And I can do a little reducing at this point. See, 1/3 of 36 is 9. And so when I go ahead and multiply 9 times 10, I'm left with 90 pi. And so now I've got a division problem. Remember, I was going to divide, see how many cones go into the cylinder, and that's what I'm doing here. So I didn't need to multiply pi times the number, because when I do the division, I'll go ahead and rewrite it a little bit more clearly. I got 3600 pi divided by 90 pi. And you see the pi's will cancel out, along with these zeros. And 9 goes into 36 4 times, with 1 0 left over, so 40. So what it's going to take is, we'll have to fill the funnel. We'll fill the funnel 40 times. 40 times to fill the cylinder. So let's take a look at our next one. It says find the height of the cone. So we want to know the height of the cone whose volume is equivalent to the cylinder below. Well, what we're going to end up having to know, though, is the cone's radius. We're going to say the cone has a radius of 6 centimeters as well. So the cone's radius is going to be the same as the cylinder's radius. And then we're going to go ahead and find out how high does this cone have to be to have the same volume. So let's take a look at what we got. Pi r squared times by the height. That's our formula. Well, the volume for the cylinder, or for the cone, is going to end up being, this was the cylinder, volume for the cone is going to be pi r squared times by height as well, but we got to take 1/3 of that. So we want these to be equal, because they say what will the height be to make the volume equivalent. So we're setting them equal rather than dividing them this time. Well, since the radius is the same, see, I can go ahead and I said it was the same here, 6 squared, and h is 10, I know that, so let's go ahead and substitute that number in there. And so I've got a 10 in here as well. And so that's multiplied by, and I've got 1/3, and I got pi, and then 6 squared again times by h. I just don't know what this h is. Since I've got some things that are the same on one side, let's go ahead and do some division. See, I can divide by pi right now, and those pi's will cancel out. I've got this 36, and I'll go ahead and write it out there. 36 times 10 equals 1/3, and then I've got the pi's canceling out here as well, so 6 squared is 36 times by h. Well, rather than taking 1/3 of 36 right now, look, I've got 36 on both sides. Let's divide by 36. And you see what happens is those 36's cancel. So now I'm left with something even smaller. I've got 10 equals 1/3 h. So all I have to do from this point is get rid of that 1/3. And to get rid of that, I'm going to multiply by 3. And so that'll leave me with my answer, which is 30. So 30 centimeters is going to end up being the height of this cone if it's going to have the same volume as the cylinder. Well, those are the types of problems you're going to see on tonight's homework. Good luck.